All right, welcome to The Explainer. Today, we're going to tackle one of the biggest ideas in all of science fiction and ask a really simple question. Could it ever be real? I mean, for decades, right? That promise, it has completely captured our imaginations. And it was all made possible by one single iconic piece of tech. So could Star Trek's warp drive actually be a thing? To figure that out, we have to take a journey ourselves. A journey from the final frontier of fiction all the way to the front lines of real cutting-edge theoretical physics. Okay, let's get into it. Okay, so first things first. Why do we even need something like a warp drive? What makes it so essential, not just in Star Trek, but for any of our own dreams of traveling between the stars? Okay, look at this number, 4.3 light years. That's how far away Proxima Centauri is, the very next star over from our sun. Now, that might not sound like a lot, but to put it in perspective, if we took our fastest spacecraft right now, something like Voyager 1, and pointed it in that direction, yeah, you'd get there in about 75,000 years. I mean, the distances are just staggering. And look, a 75,000-year journey makes for a pretty boring TV show, right? And an even slower way to explore the galaxy. So, yeah, the writers of Star Trek came up with a pretty brilliant solution. So let's peek into the engine room, shall we? Let's look at how Starfleet's tech evolved over time to crush these insane distances. It's a masterclass in sci-fi world building. And in the Star Trek story, it all kicks off with this ship, the Phoenix. This single flight is this huge, pivotal moment for humanity. It's basically us putting up a sign that says, hey, we're ready to join the galactic neighborhood. And that's what gets the Vulcans to show up and say hello. And you can see here, Starfleet tech is always evolving. You've got your standard warp drive, that's the reliable workhorse, powered by a classic matter-antimatter reaction. But they're always pushing the limits, right? You get these more exotic and, frankly, way more dangerous alternatives. Things like the Borg's transwarp, which uses these crazy subspace tunnels, or the quantum slipstream drive. And then there's the spore drive, which is literally instantaneous, but you kind of need a rare living creature to navigate it. So, trade-offs. Okay, this is all great sci-fi, but how does any of it connect to real science? Well, here's where it gets really, really cool. It turns out the core idea behind warp drive isn't just pure fantasy. It's actually rooted in one of the biggest, most mind-bending ideas in all of physics. And it all comes down to Einstein's theory of general relativity. It tells us that space and time, they aren't this fixed, rigid background. They can be bent and stretched and warped. The classic analogy is to think of space-time like a giant taut bedsheet. You put something heavy on it, like a bowling ball. What happens? It creates a dip, a curve. That curve is what we feel as gravity. So here's the trick. A warp drive doesn't try to push a ship through space faster than light. We know that's a big no-no. Instead, it creates a warp bubble. It literally moves a chunk of space itself with the ship just sitting safely inside. It does this by compressing space in front of it and expanding space behind it. So the ship inside the bubble is basically just chilling, not breaking any local speed limits. But the bubble itself, it's surfing on a wave of space-time and can get where it's going incredibly fast. Okay, now this is my favorite part. The really wild thing is how this sci-fi concept directly inspired a real scientific breakthrough. And I mean, the link is so direct, it's almost unbelievable. Check this out. In 1966, Star Trek hits the airwaves and popularizes the whole idea of warp drive. Fast forward to 1992. A physicist, Miguel Alcubierre, who's a huge Star Trek fan, is watching an episode of The Next Generation, and it gives him an idea. Just 2 years later, in 1994, he publishes this paper, The Warp Drive, Hyper-Fast Travel Within General Relativity. He literally laid out a mathematically plausible model for a warp drive. He took a TV show idea and turned it into actual physics. And this slide just illustrates that connection perfectly. On the left, you've got the fiction, right? The USS Enterprise in its warp bubble. On the right, that's the real physics. That's a plot from a NASA paper visualizing Alcubierre's math. It shows exactly how you'd need to shape space-time. The big peak is space being compressed in front, and that big dip is space being expanded behind. It's a scientific blueprint for a warp drive. So, Alcubierre proved it's possible. On paper, the math checks out. But in practice, well, there are a few hurdles. And by hurdles, I mean absolutely monumental physics-breaking problems. So what's stopping us from just building one? The math works, right? Well, the problem isn't the recipe, it's the ingredients. And one of those ingredients is so extreme, it basically borders on impossible. To get that expansion of spacetime behind the bubble, the equations call for something called negative energy. This is a hypothetical kind of matter that would have negative mass. We've never seen it, we have no idea how to make it. It's basically the real-world unobtainium of warp drive physics. And we're not talking about just a little bit of it. The early calculations, they required an amount of this negative energy stuff equal to the mass of the entire visible universe. Now, to be fair, later research, guys like Sonny White, they refined the math and brought that number way, way down. But the fundamental problem is still there. You still need this exotic matter we don't have. And that is the biggest roadblock by far. But the story doesn't just end there with a, well, it's impossible. The quest for warp speed is actually entering a totally new and maybe, just maybe, a much more plausible chapter. So scientists started thinking, what if we forget about faster than light for a minute? These new models are for subluminal warp drives, so no, they can't break the light barrier, but they could still move a ship at, say, 10% the speed of light by warping spacetime. And the really important part? They could do it without needing any of that negative energy unicorn dust. These new ideas stick to the known laws of physics. And this isn't just scribbles on a whiteboard either. People are actually testing this stuff. At NASA's Eagleworks lab, they built this thing, a warp field interferometer. The whole point was to see if they could generate and, more importantly, detect the tiniest, most microscopic spacetime distortions, the kind predicted by these newer models. We're talking about a real experiment trying to create a tiny warp bubble in a lab. So let's just recap the big takeaways here. First, Star Trek's crazy idea actually inspired real physics. Second, the original Alcubierre drive, it's mathematically sound, but it needs that exotic negative energy. Third, these newer subliminal models might actually be achievable with physics we already understand. And finally, the dream of warp speed is something scientists are actively researching today. What started as just a way to get the story moving has become a real field of scientific inquiry. So, the big question remains, will science fiction one day become science fact? The whole journey of the warp drive from a TV screen to a NASA physics lab really shows you something powerful. Sometimes to actually reach for the stars, you have to start by dreaming about them first. Thanks for watching.